SnappyHexMesh is OpenFOAM's advanced meshing tool used for complex geometries imported from CAD STL files. Okay, so let's start this one, like where you can find this SnappyHexMesh and how to perform basically SnappyHexMesh. Okay, operation or code. Okay, so let's go to the foam tutorial once again. Oh, sorry, I forgot to put $sign. Okay, then we have to go inside mesh, then we have to go inside. You can see that a snappyHexMesh directory is here. Okay, so snappyHexMesh, then you will find here many options are there, but for this lesson I'm using this sphere gap closure. Okay, all right. So here inside all the files will be there. If you'll go inside system, you will find SnappyHexMeshDict. Okay, so whenever you wanted to use SnappyHexMesh, you have to first prepare the SnappyHexMeshDict. Okay, so let's go inside SnappyHexMeshDict. Okay, so here you will find these three: Castellated mesh, snap, and add layers. Okay, so basically Castellated mesh is the base mesh which cuts around geometry. Like you have made a rectangular, like for example, okay, so let me tell you from the starting. So first, before making this SnappyHexMesh, we prepare a general rectangular mesh with the help of blockMesh. All right, then what we'll do, we wanted to insert some complex geometry, like for example, if you are doing a motorbike analysis. Okay, motorbike analysis is a very famous OpenFOAM simulation. So if you wanted to run that, so what you wanted to do, you can make the motorbike in using any of the 3D CAD software, convert that, save that file into .stl format, save it inside one place, which I'll tell you after explaining this SnappyHexMeshDict. And after that, you just make this SnappyHexMeshDict directory. Okay, and then you run, after blockMesh, you run the snappyHexMesh command, and that motorbike domain will be cut and will be inserted inside the rectangular domain which we have created using the blockMesh. All right, so this castellated mesh will basically run this one, the cuts, basically cuts around the geometry. Snapping, this is this is the snapping one, so this confirms the mesh to the geometry. And this add layers means like it adds the boundary layers for better mesh resolution near the walls. Okay, so these are the basics one which you must know. Otherwise, other things are like common, and it is like changing according to case. Okay, other things inside the SnappyHexMeshDict. All right, so this is the advanced thing. Okay, so I'm not going in this lesson, my focus is only on how to use SnappyHexMesh. Okay, so that is the part. So let's go back, and to see how to use it, we will be copying this from OpenFOAM tutorials to our home directory and check how to run it. Okay, so let's copy this sphere gap closure, and I will just like, okay, then I will go to my home directory by pressing cd. Let me clear the terminal. So you can see that sphere gap closure is here. Okay, sphere gap closure is here, and we will go inside the system. Okay, so first let us run blockMesh. Okay, so we come out of the system directory and run blockMesh. Okay, yes, so a simple mesh has been created. Let's check in paraview. So first we will create .foam file, then we will open this .foam file in paraview. Okay, so yeah, I'll press apply, and you can see a simple rectangular domain mesh has been created. Okay, and inside it we will be putting that geometry which has been created using a 3D modeling software. Okay, so I'll close it. Okay, so where first you have to save it. Okay, where you have to save it, that file, the 3D model file in .stl format which is there. So you have to save it. Where you have to save it, you have to go inside the constant, and then you have to go inside the try surface directory, and here you have to save it. Okay, so if it is not there, so first you have to go inside the constant directory. Okay, like if you are making another case, okay, constant directory, then you have to make the try surface directory by this command, try surface. Okay, so a directory will be made. Because it is already made, so I'm not going to make it. I'm not pressing enter. Okay, I'm just type the command. So a try surface empty directory will be made, and inside that try surface directory you have to copy the 3D this dot the 3D model which you have made in the .stl file. All right, that has been done. After that, then you will go inside the system directory, and then you will make the relevant snappyHexMeshDict. Okay, after preparing this dict, you only have to run snappyHexMesh. Oh, I have typed, okay, I forgot, snappyHexMesh, and press enter. Okay, so it will take some time to complete because it is a complex operation, and after it will get completed, it will make your geometry in the way you want. Okay, so like it is used, for example, some you have to put there is a rectangular domain, and you have to put some obstruction in between, some type of obstruction like rectangular obstruction, a circular pipe, anything. Okay, so this snappyHexMesh is a very useful tool for that. Okay, so for that you have to first prepare snappyHexMesh. Okay, you first have to prepare a 3D model and save it in .stl file. Where you have to save it, I have told you, and then you have to prepare this one, the this snappyHexMeshDict, and you have to perform after that snappyHexMesh command. Okay, so let's open it in paraview, phone, and I'll press apply. So yes, you will find that our mesh has been, initially when we have ran the blockMesh, how it was a rectangular domain. Now what it has become, a sphere one. Okay, so what has happened is, like, in that rectangular domain, what has happened, okay, so basically, okay, so like, okay, let me explain this and I'll tell you about that. So so what has happened is, like, inside the rectangular domain, this sphere has been inserted. So what you can see in this case, what they've done is, like, they have removed the rectangular part. Initially the rectangular part is there, right? So they have removed the rectangular part, but in many cases what happens is, like, that rectangular domain remains and only small things will be there. Like, for example, in the motorbike, if you can see, if you find the images of a motorbike, a simulation on, if you will google it down, then what is there, like a rectangular domain is there and a small bike has been inserted and been placed here. Okay, so that is happen, or you can remove that part. It's up to you, it's up to your use. Okay, it's up to your case. Okay, so like this, because with the help of the blockMesh you cannot make this circular. Okay, because blockMesh only make a rectangular domain. Okay, it will not make this complex spherical or triangular or any other hexagonal or any other shape. Okay, so that is the thing. This is a specific case of a sphere, so they do not wanted to use, because it will be like for running a CFD simulation, you have to remove as much part as you can. Okay, you only keep that part that is being required in your simulation. Okay, because unnecessary, it will use your computer simulation time, it will increase your simulation time, and it will use your computer resources which is not required, and it will make the simulation slow. Okay, so that will not be feasible. All right, so that is the thing, that is the thing. All right, so yeah, so like this you use snappy hex mesh.